Hello everyone, let's look at this interview question. It's not on Leetcode, but it will be found on interview questions, particularly on meta interview questions, one of the top questions they have, and it's move zeros to the left. The Leetcode questions is move zeros to the right, but this one's to the left and it's a little more difficult. So we are given an integer array, and we have to move all the zeros to the left while maintaining the order of other elements in the array. The array has to be modified in place. Let's look at the following integer array: 110, 20, 0, 59, 63, 0, 88, 0, and on the top are the index values. After moving all zeros to the left, the array looks like this. Okay, so all the zeros are on the left. We have to maintain the order of the non-zero elements. Okay, to solve this problem, we first define the length of the array to be less than 1, in which case we return. This is our base case. This means the array is not big enough to even move zeros to the left. Then we define the length A to be of length A. In order for us to define our pointers, we define the right pointer at right index length A minus 1, and the read pointer index at length A minus 1. So the rightmost value of the array index we start at the end. And this makes sense because we need to iterate all the way to the left and check how many zeros we run into. And this while loop defines exactly what these pointers do. We check if the read index is first of all greater than or equal to 0, in which case we can proceed. And then we check if the read index is not equal to 0. If the read index is not equal to 0, then we can simply define the array at right index to be the array at read index. And this makes sense because we only move the right index when the value at the current right index is not 0. This means that as we iterate all the way to the 0 value, the read index will always iterate even if it's a 0 or non-zero value. So there will eventually be a gap between the zeros and non-zeros that are being iterated. Since the right index does not iterate past non-zeros, but the read does, a gap will be formed and the read will reach index 0 first. So then we do this final while loop and check. Right index greater than 0, A right index equals 0. This just means that while there have been zeros, this has made it so the right index has ended up at some arbitrary non-zero index value, making it so we have to define the current right index to be 0. Because from there on, it's going to be 0 values from the point of that to the left. Okay, let's just go through this example and make sense of it. So in this first example, we have defined to be the right index and read index to be 8. We do the while loop and check. Is the read index greater than or equal to 0? Yes. Okay, then we enter the while loop if index A read is not equal to 0. This is true. It's 9. 9 is not equal to 0. A write is equal to A read. It's already read and write at the same pointer, so we don't really need to define anything. Next, we move the write index by 1 and the read index by 1. Next iteration, is A read index not equal to 0? No, it's actually a 0. So we skip this if condition and move the read index only to the left. Next iteration, 8. Is A read index not equal to 0? It's actually not. So that means that A write index is equal to A read index. So remember, write is at 0 here, read is at 8. So A write index is equal to A read index. So this becomes 8. 8. And we can move the index value to the left for both pointers. Next iteration, 6. 6 is not equal to 0, so 8, once more, becomes 6. And then we can move this to the left, and this to the left as well. Next iteration, A read index not equal to 0. This is true. That means A at right index is equal to A at read index, so 6 becomes 2. Okay, then we move both pointers. The first pointer being moved to the left is the right index in this if condition, and then always the read index moves to the left. Next value, in the while condition, read index is currently 0, 1, 2, that's greater than or equal to 0. If A read index is not equal to 0, it is equal to 0, So we simply move the read index and do nothing with the write index. Same thing, a read index not equal to 0, so we move the read index only. And then finally we're at a 5, and we say, is read index greater than or equal to 0? It is 0. Index 0 is equal to 0, so a at read index is 5. 5 is not equal to 0, that's true. So a write index is equal to a read index. So this is where write is at currently. So 2 becomes 5. Read index minus 1, we exit the out of bounds, so we exit this while loop. And as you can see, there has been a gap of 3 zeros made by every iteration for read, and the write iterations only for non-zeros leads us with 3 spaces from the zeros. So while write index greater than or equal to 0. Almost done. So a write index is equal to 0 from then on out. So we're currently at 5. Okay, write index is, so it was at 5. We forgot to move this index because we defined 2 as 5 and we had to move it. So this is 0 now. Write index minus 1 becomes 0. Write index minus 1 becomes 0. Okay, so the final array will be 0, 0, 0, 5, 2, 6, 8. 9. There should be a 9 here. We didn't redefine 9 because we initially started there. But yeah, so you see that all the non-zeros move to the left. Let's run really quickly through this last example. So we see that we have to define write and read to the final index. And we define the length a minus 1, 0, 1, 2, 3, 4, 5. We're starting at index 5. We enter this while loop and we check if the read index is greater than 0. It is. And we check if a read index is not equal to 0. This is not true, so we simply subtract the index from read. Apply the same logic with this if condition. It's another 0, so we simply move the read pointer and not the write pointer. Okay, same thing happens here. It's not equal to, it is 0, so we exit this if condition, we don't enter it, and we enter a next iteration, just moving the read pointer once more. And finally we arrive at 5, and this is not equal to 0, so write becomes from 0 to 5, because array at index value 5 is now equal to the array at index value 2. So that's 5. We subtract 1 pointer from both the read and the write, 1 from the if conditional, and 1 always for the read. Next iteration, check 4, not equal to 0, so this value here becomes 4. A at index 0, 1, 2, 3, 4 is now equal to the value of array at index 1, and that's 4. Okay. Read becomes this final index value, and the write pointer points to this next 0 here, and we check if array at read index value, that's 1, not equal to 0. So the array at write index is equal to the array at read index. So that means (1, 4, 5). So this current index is 1 now for the write index. And we subtract 1 from the read index, and now it's out of bounds. So we exit this while loop. We enter the final while loop, and we say, while the write index is greater than 0, it is. Don't forget, it's at 5 now. It's at 2 index. We set this value to 0. It's at 2 because every time we write to this index value in this if condition, we have to subtract, and I forgot to subtract there, so this becomes 0, 0, 0. So the final array value are 0, 0, 0, 1, 4, let's see, 1, 4, and 5. Okay. And then all we have to do now is print the values. V is equal to move zeros to the left, V. We call the function value. It rearranges in place, so we don't have to define a new array. and it returns these values 0, 0, 0, 1, 4, 5. Okay, let's check the solution. So this first array is 1, 10, 20, 0, 59, 63, 0, 88, 0. Run it, and it turns all the zeros to the left, so it becomes this. Very nice. So what is the time complexity of the solution? Time complexity of this function is O of n, where n is the length of the input array A. This is because the function iterates through the array twice, wants to move all the non-zero elements to the right of the array, and wants to fill the remaining left side of the array with zeros. Both iterations have a linear time complexity. The space complexity of this function is O of 1 because it uses a constant amount of space. The function only uses a few variables to keep track of indices and does not create any additional data structures that grow with the size of the input. That's it for this problem. Thank you for watching.